Welcome to the channel Professor Davinci. Central limit theorem. The central limit theorem states that distribution of a sample approaches a normal distribution as the sample size gets larger irrespective of what is the shape of the population distribution. So here you need to understand the two terms, what is population and what is sample. So here the two terms are here, sample and the population. So population meaning, say population. Population meaning, suppose if I want to do a research on the forest, say I am going to do a research on the forest. So the forest may contain say around say 1000 trees. Forest may contain 1000 trees. So suppose assume that this is the forest. Here we have 1000 trees. Okay. Now it is not feasible to go to the entire forest and do a research on 1000 trees one by one. So instead what I do, I would make a sample space or sample. Sample means I take a small portion of the forest. For example, say this is a small portion of the forest. Say this is the one. Okay, another sample, small portion too. Okay, now this small portion of the forest is called a sample. Okay, that means in mathematically we can say sample is the subset of the population. Okay, so this is called the new term. You need to remember population and the sample. Now let's come to this one. Few points to note about the central limit theorem, which is central limit theorem states that the distribution of the sample means near a normal distribution. Okay, so the first property of the sample, let me erase this one. So if we take the sample means always will be in the normal distribution. What is the normal distribution? Normal distribution is the bell curve irrespective of the size. Okay, when the sample size is, suppose for example this I can say this is for around 40 sample size, 40 samples. If the sample size gets bigger, the sample size which is equal or greater than the 30 or considered enough for the central limit theorem to hold. So I told you that I have a population of a forest. Okay, I have say 1000 trees. What is the minimum size of the sample I must have to take? I must have to take the small portion of the forest which consists of not less than, that is greater than or equal to 30 trees. Okay, so my sample size must not be less than 30. It must be always equal to or greater than 30. That is considered. If the sample size is greater than or equal to 30, then this central limit theorem will be true for the sample. Now say assume that 40 is a sample. So for sample size 40, it resembles the normal distribution, and if the sample size increases, it may have more clear sample, normal distribution. Suppose this is a 50. So likewise, when the sample gets larger and larger, the bell curve or the normal distribution will be perfect irrespective of the shape of the population. So the complete entire population may have the skewed distribution, either the longer tail in the left side or may have the longer tail in the right side. This is called a skewed distribution, but the sample always holds the standard normal distribution. Next, the key aspect of the central limit theorem is the average of sample mean, and the standard deviation will always equal to the population. So I have, say, let me erase this one. The average sample mean, for example, I have, this is the sample 1, sample 2, sample 3, sample 4, sample 5. Assume that there are only 5 samples. So this is a sample 1, sample 2, sample 3, sample 4 and sample 5. Here states that the average sample mean, the average sample mean and standard deviation and standard deviation will always equal to the population's standard deviation, and always this one sample mean also equal to the population mean. Okay, this is the property the central limit theorem holds. A significantly large sample size can predict the characteristics of the population very accurately. So if a sample size increases, it gives the perfect and exact inference of the population. Now, here you need to consider that the central limit theorem is the statistical theory stating that given a significantly large sample size from a population with finite variance, the mean of all samples from same set of population will be roughly equal to the mean of the population, right? This holds true regardless of whether the source population is normal or skewed, provided that the sample size is significantly large. Okay, now here I need to do one thing. For example, traditionally what we do, for example, let me erase this one. Traditionally what we do, suppose for example, consider there are 50 houses. Consider there are 50 houses in your area, in your locality, and each house has say 5 people. Each house has 5 people. Now our task is to calculate the average weight of the people in your area. So now what is our task? Our task is to find the average weight of the people in your locality. Usually what you do, first step, measure the weight of all the people. First step, we will measure the weight of all the people. Second, we will add all the weight. We will add all the weight. Third, divide the weight by the total number. That is, we will find the average. This is how we do traditionally. However, here the problem comes. If locality, no problem, 50 houses, I may do this one in 2 or 3 days. However, if my population is enormous, that is, I want to calculate the average weight of entire town or entire city. Assume that entire city of Paris having 5 million houses. Okay, in this 5 million houses, it is not feasible to measure the average weight. So in this problem comes. For this problem, we go for the alternate approach. What is the alternate approach? As a workaround, we have an alternate approach that we can take, that is central limit theorem. Here in this case, we need to go for central limit theorem. To start with, draw the group of people at a random from your area or city. Here we call as a city of 5 million houses. We will call this as a sample. So for now what I have, from this 5 million houses, I take a sample, first sample, say sample 1. Sample 1 of say around 40 houses. Okay, and then another sample, I can take sample 2 of another 40 houses, sample 3 of another 40 houses. So likewise I can take some few samples. We call this as a sample. We draw the multiple samples in this case. So each sample must contains not less than 30 people. So I just taken 40 people in each sample. Calculate the individual mean of each sample. Okay, so calculate the mean. So what I'm going to do, I'm going to find the mean of sample 1, and I'm going to find the mean of sample 2, and I'm going to find the mean of sample 3. Okay, then this is the third point. Calculate the mean of the sample. Okay, calculated. To add up this in a histogram for a sample weight, and the people will resemble the normal distribution as stated here. If the sample the mean of the sample will always be the normal distribution. So if we populate this on a histogram, it will have a normal distribution, and however the sample average will be equal to the average of a population. So instead of going to 5 million houses, I take this sample, I find the mean. So this mean of all these sample, the average mean of the sample will be equal to average mean of a sample will be equal to the mean of a population from the theorem. So I am now going to each and every houses of 5 million houses. I'm going to just going for a 40 here and there, 40 samples. I mean 40 people consist of a single one sample. So I collect few samples here and there across the city, and then I find the mean of those samples will be equal to the mean of the population. So the work will be very easy with the use of central limit theorem. Clear? So mathematically what we can say, this is a mu x bar is the mean of a sample will be equal to the mean of the population, and the standard deviation of a sample, all the samples will be equal to the standard deviation divided by root n. So mu is the population mean, and sigma is the population standard deviation, and the mu x bar is a sample mean, and sigma x bar is a sample standard deviation. Okay, clear? Now let's go with a small exercise example. In France, the recorded weight of a male population are following a normal distribution. The mean and the standard deviation are 68 kg and 10 kg respectively. If a person eager to find the record of 50 male in the population, then what would be the mean and the standard deviation of the sample? Clear. So what is given in the statement? Statement mean population equal to 68 kg, and the population standard deviation is at 10 kg, and the sample size is 50. Solution: the mean of the sample is same as the population. Obviously, as we told here, the mean of the sample will be equal to the population, and the sample standard deviation is calculated as, what is the sample standard deviation? Sample standard deviation x equal to sigma by root n, so which is equal to 10 divided by root 50, which equals to 1.41. So in this case we have found the sample standard deviation and the sample mean. So this is, what is the sample mean? Sample mean is always equal to the same as the population, that is 68. Not this one, mean. So this one sample mean equals 68, which is equal to the mean of the population. This is as per the theorem, and the standard deviation of the mean equals the standard deviation of the population divided by n, so which we will get 1.41. Understand? This is how the central limit theorem works. Clear? So central limit theorem is a very essential theorem in the statistics. This is especially, it is used for the prediction of election results, or a prediction of say product distribution, or to get the feedback from the product likeliness. So all the way we use this central limit theorem. Is a very important topic and very important theorem in statistics. I hope you understand. Clear? See you, bye bye. Have a great day.